This presentation will help deconstruct the Georgia Standards of Excellence for 5th grade math, numbers and operations with fractions. Standard 5, which is as follows. Students are to interpret multiplication as scaling or resizing. This particular standard has several smaller components. In 4th grade, students learn that fractions can be expressed as multiples of a unit fraction. For instance, the non-unit fraction 4/3 can be thought of as 1/3 plus 1/3 plus 1/3 plus 1/3, or 4 copies of 1/3. Students then extend their previous understanding of multiplication as repeated addition of whole numbers to fractions and express a non-unit fraction as the product of a unit fraction and a whole number. So before entering grade 5, students explore the concept of multiplication as repeated addition and multiplicative comparison. In 5th grade, students are introduced to a new concept of multiplication, that is, scaling, also known as resizing. This opens the door to multiplication of whole numbers by fractions, fractions by fractions, and finally, mixed numbers by fractions. In order to develop strong fraction number sense, both 4th and 5th grade students must be able to assess the reasonableness of a product when multiplying fractions. Students have learned since 3rd grade that multiplication generally leads to products that are greater than the factors. In Standard 5 and F5, however, they will develop a much more fluid understanding of the relative magnitude of products. Teachers should help students focus on what a product would look like prior to actually calculating. By asking questions such as, will the product be less than or greater than a certain number? How do you know? And does this product make sense? Will also help students gain a deeper understanding of multiplication as scaling. Essential questions should be translated into I can statements or learning targets, which will help direct student learning. It's always a good idea to start by building on prior knowledge, so let's take a look at a small group of students reasoning about the relative size of factors with a whole number multiplication equation.
Okay, so if it's asking us what number should go in the box to make this statement, that means that this would be half. Since this is 11, it's got to be 1,706, right? Nope.
No.
It would actually be 6,824
because 22 is 2 times 11, so you'd have to also multiply the for other factor by 2.
Oh, okay. I was doing
So
divided by 2.
6,824.
Oh, because you're doubling your final.
Yeah.
I was dividing it by 2.
Yeah. In order to get the same result.
Oh, okay.
In 5th grade, a common error is that students often think that multiplication will result in a product with a value greater than both factors. This is not true when a factor is less than 1. Students need experiences exploring arrays and other representations with factors less than 1. Observation and discussion are extremely valuable in clearing up this misconception. This standard relies heavily on estimation, which plays a big role in students' development of strategies. Therefore, teachers should keep the focus on the meaning of the numbers and operations. Without a firm grasp of fractional concepts, standard algorithms become rule-oriented and confusing. In the following video, several students are playing a game that encourages reflective thinking while helping to build informal number sense with fractions.
Products is less than both factors.
Both. Okay, so flip over my 5 that I have drawn.
9, 10, 9, ace, and a 6.
So ace is 1, and
Product has to be less than both factors.
so I know that if you multiply a fraction for this game, I'm going to put 1/6. A fraction multiplied by a fraction, if those fractions are both less than 1, then it will get you a product less than both fractions because multiplying fractions is taking a part of something.
Standard NF5 is comprised mostly of the use of estimation in number sense rather than the actual computation. We want students to focus on the factors of a given multiplication sentence in order to reason abstractly about the possible products. In this example, we will use 2 times 5 and compare it with 4 times 5. Since both expressions have a factor of 5, we can focus our attention on the factors 4 and 2. By using an array, we can see that the factor 4 is composed of 2 sets of a 2 by 5 array. Therefore, we can state that 4 is double 2. Because we doubled the size of the array, it can be seen that our product doubled as well. Also, students should recognize that the reverse is true and that 2 is half of 4, so the product should then be half of 20. At this point, 5th grade students have been modeling multiplication with arrays since 3rd grade. Most students should be able to think abstractly about these expressions, but manipulatives should be made readily available to any student who struggles. with this concept. For the second part of NF5, we involve fractions as one of our factors and reason abstractly about how that fraction compares to one whole in order to estimate our product. Students by this point should know about the identity property of multiplication, which states that if one of our factors is one whole, then our product is equivalent to the other given factor. For example, 3 times 1 is equal to 3. We want students to use this concept to think about fractional factors in comparison to one whole. In this next expression, we can identify two ideas. First, that both equations have a common factor of 3. Secondly, the second equation has an improper fraction, which means that it is greater than one whole. At this point, we want students to reason that from these two ideas, we can then say that our new product should be larger than 3 wholes. Using drawings, students can compare multiplication expressions to each other and see what is happening to the products. As you can see, 3 groups of 5 halves is larger than 3 groups of 1 whole. From here, we want students to form their own rule about multiplying by fractional factors greater than 1 whole. After introducing multiplying given numbers by fractions greater than 1 whole, we revisit multiplying given numbers by fractions less than 1 whole. This concept is a continuation of what students have previously learned in 4th grade and should be presented to students as an addition to their prior knowledge. Our example begins with 2 equations, 5 times 1 and 5 times 1/2. 2 ideas should be noted. 1, that both equations have a common factor of 5, and 2, that the second equation has a fractional factor of 1/2. Since 1/2 is less than 1 whole, we want students to reason that this product should be less than the product of 5 times 1. By having students represent the equations with either bar models or other drawings, they will be able to make the connection between the two products. We can clearly see that 5 groups of 1/2 will in fact be less than the product of 5 groups of 1 whole. It is at this point where teachers should be asking students to create their own rule for estimating products involving fractions. In the following video, you will see and hear several students using reasoning to decide on the products of fractional factors without using computation. You will also hear the teacher directing their thinking as they move through solving the problem. While the students are exploring this concept, the teacher should be listening and looking for the following.
Determine whether the product will be larger or smaller than the first factor. So we have to look at the 2 factors and just kind of estimate to see what the answer will be. So I know that 3/3 is actually equal to 1. So that's basically 3 1/4 times 1, which is the same as the first factor. So that'll be equal
times
to
1 1/2. Well, if you multiply anything by 1 1/2, you're getting more than what it is because 1 1/2 is more than 1, so it would be more than 14.
I'm going to do this one.
Mm-hmm.
So when you multiply a whole number by a fraction, you're taking a part from a whole, so you would get a part.
The following are a few task tools and formative assessments that can be incorporated into your lesson 4-5 and F5. This tool provides students with a connection between a story problem or context, paraphrasing, models, and, of course, procedures. The following video shows how to implement this tool into your conceptual teaching of the standard. Using the conceptual math tool will help students build an understanding of the relative magnitude of numbers when one or both of the factors are fractions. Students simply enter in the phrase, such as 6 times 2/3, lock the phrase in, and you're able to choose a paraphrase. So we'll go with multiplier or groups of the starting value. And we'll grab the 6, so it's 6 groups of 2/3. It automatically builds the model for the students, and they can switch the model in order to see groups of whole. And as you can see, that 6 times 2/3 gets me 4. So this particular product is less than the original factor of 6, but greater than the factor of 2/3. The following tasks have been taken from illustrative mathematics and have been placed in a progression that will allow students to make sense of each task and then use their prior knowledge to help solve the next one. Each task includes a deep context, commentary about student thinking or misconceptions, possible visual models, and solutions. These tasks are best used in a small group or as a center. Games are an excellent resource to employ to have students use the strategies they've learned in a fun and engaging way. The following game is called Fraction Factor Shuffle and requires the students to reason about the products of fractional factors given a certain condition. The game boards and directions can be located in the digital resources section. The 4 tasks listed here have been designed with a 1, 2, 3 scale rubric in mind, so that they can be used as formative assessments either in a whole group or small group setting.